Welcome to Science Soup. Today, we will be discussing the physics that you have learned or will be learning in your high school. So, it will be focused on the curriculum of physics of class 11 and class 12. But if you are curious about what's all there in physics, say in general, then check out this video where I have narrated the story of physics in less than 8 minutes. Students take up physics as a discipline with the purpose of pursuing their future careers in basic science or professional courses like medicine, engineering, or technology. But what about you? Have you ever wondered why you are studying this subject? Is it because you think you like it? Or is it because you score a wholesome score in class 10 science? Or is it because you don't have much choice? I hope you know the answer to this question for all good reasons. Alright, let that be. Now, you may be very much familiar with expressions such as the maths teacher saying, maths is life, or biology teacher saying, biology is life, or the Sanskrit teacher saying, Sanskrit is the essence of life. So, don't get carried away when you hear physics is life, because that's not what I want to say. But what I want you to realize is the purpose of spending a lot of time in this subject in the next 2 years. What is essential for you is to learn the subject with sufficient background to be competent in any academic or professional courses that you may take up in the future. The subject does not end when you complete writing off the class 12 physics paper. It will stay with you. It's gonna make you take better choices. I just hope you realize the essence of such an utterly absurd and ridiculous statement one day. Okay, drama apart, let's dive into the video. And especially to students of class 11 or 12, stay till the end of the video to have a clear and better picture of what you will be learning in the next 2 years. Hope you enjoy it, and particularly if you do, make sure to like this video cause that's how I'm gonna know you like it, literally. Take a deep breath and think about what physics is. Just to be clear, I'm not talking about the definition that you might have picked up sometime, somewhere. Not that there's anything wrong with that. I'm also not talking about, physics is the study of science of motion, register, and temperature. Yeah, and also photosynthesis. Nah. To help appreciate the meaning of the word, here's its etymology, which is the origin of the word. From its roots to implicate nature or natural things, the subject took a definitive shape around the 15th century as a branch of natural science, where the studies are focused on the observation and explanation of natural things. Or in other words, physics became the subject of studying natural phenomena, especially attributed to their material or physical properties. So if you were to call yourself as a natural philosopher back then, you would start referring yourself as a physicist around this timeline. Probably to look cooler or whatever. Over time, this has evolved from what is referred today as classical physics to the relatively newly developing branch of quantum physics and the relativity physics. More of that coming soon. So today we have Wikipedia defining physics as the natural science that studies matter, its motion and behavior through space and time, and the related entities of energy and force. To most of you, I think it sounds barely descriptive or self-explanatory. I mean, it hasn't helped in figuring out about your school physics. Therefore, what we're gonna do today is to try to break down and understand the components of your high school physics, and more importantly than just to know the various branches of physics, we're gonna try to understand how these branches are related to one another. You can think of this video as more of a layout or a map rather than just a syllabus sheet. And in this process, you will have a clear and better picture of what you have learned or what you will be learning. The first chapter, Physical World, is essentially a formal or academic introduction to the subject of physics. So you can think of this chapter as what you would hear on your very first day to your school of thought at around 100 BC. Stop trying to imagine that. The deal is, this is the chapter that introduces how the systematic approach to study natural phenomena is done, how you could explain natural observations through guessing, get better as educated guessing or informed guess, which is what the hypothesis is, by the way, and keep improving it in the forms of theories and laws. And if you're studying natural things, then you better know how to express them. For what is more generally referred as physical quantity, it is any property of a material or a system that can be described but not necessarily measurable. And chapter 2 will exactly introduce what this is, how we measure them, and how we do these things around here. So we will have sub and fundamental physical quantities and their definitions. Keep an eye out for the updated definition, their SI units, and how we systematically address the errors in measurement. Make sure that you have learned the concepts of the powerful dimensionality analysis, the linguistic difference of accuracy and precision, and the essence of significant figures. These seemingly boring chapters may be unattractive to a lot of you because it doesn't carry big marks and big exams. Because these few concepts does not end with this unit or this textbook, you gotta trust me when I said that it's gonna haunt you, for they're gonna keep appearing anywhere or anytime, be it your physics honors laboratory or you're just calculating your savings or just reading a newspaper. Now as for kinematics, this is where the classical mechanics starts. The next 3 chapters are the pure, unadulterated classical physics lessons that you could have from this guy himself, and to the reason why they are referred as classical, these topics are established and they have become the standard. There's no refuting these theories. For all intents and purposes, they are the unshakable truth of physics. Very broadly speaking, before we have relativistic mechanics and quantum mechanics, we had the fundamental classical mechanics. We further saw the evolution of classical mechanics as we want to apply them to more than just rigid bodies. We wanted to see how our understanding can be extended to objects with deformable shapes and sizes, for we have deformable body mechanics and fluid mechanics. But for now, let's focus on this classical mechanics, or to be more specific, this rigid body mechanics. If you remember the definition provided by Wikipedia, physics studies matter and motion, along with the energy and forces involved in it. On this basis, depending on how far you want to study all these physical quantities, the rigid body mechanics can be subdivided into statics and dynamics. In statics, we study non-accelerating system, meaning that the objects in the system will either be at rest or in uniform motion. And in dynamics, we study systems that has non-zero acceleration. Or if we could ignore the technical disparity for a moment, for the sake of simplicity, statics is about study of forces of objects at rest, and dynamics is the study about objects in motion. This dynamics can be further subdivided into branches of kinetics and kinematics. In kinetics, we consider the forces involved in the motion, while in kinematics, we are interested only in the motion regardless of the forces causing them. And this kinematics is what you will learn in Unit 2. After understanding the concept of frame of reference, we will start with the basic and simple concept of motion in a straight line, where we will learn to draw and interpret position time graph and define speed, velocity, or draw velocity time graph to define acceleration. This is where it could get a little bit cranky for some of you because there are maths involved in it, but allow me to show you that that is not the right approach, because as they say, maths is the language of physics. As a matter of fact, credit goes to Sir Isaac Newton for inventing calculus because he wanted to apply his kinematics laws of motion to the planetary objects, which happen to move in non-rectilinear motion. You need to realize that the introduction of these topics are only at the elementary level and are not to be any short of challenge to understand them. So we will have introduction to the elementary concept of differentiation and integration for describing motion. We will also be talking about vectors as a class of physical quantities, their algebra and how you can resolve them. And if you have understood them, then it's going to be really easy to understand concepts of relative velocity or projectile motion or uniform circular motion. The rest of the chapter will be about how to draw the velocity diagram correctly, after which analyzing them would be so much easy. To emphasize, make sure that you got these elementary concepts because it does not end with class 11. Their application will come up in class 12 as well. Remember that class 12 physics is not advanced version of class 11 physics. It's more of class 11 as part 1 and Class 12 as Part 2 of High School Physics. Moving forward, we will focus on force, which will be chapter number 5. We will have the concept of inertia and Newton's first law of motion. Then we will have the concept of momentum and Newton's second law of motion. And finally, we will have the concept of impulse and Newton's third law of motion. Then you will have the opportunity to see how conservation laws work in nature. Here, you will have the law of conservation of linear momentum and its applications. This will be followed by a very fun and interesting analysis of system of forces where you can see how your intuition about everyday objects and their interactions can be translated into mathematical models and their analysis. Make sure that you have learned to draw free body diagrams properly, and you will nail all the consequent analysis involving equilibrium or concurrent forces, static and kinetic friction, rolling friction, lubrication, the dynamics of circular motion, centrifugal force or the centrifugal force. At this point, I would advise you to truly evaluate yourself about what you have learned so far, because the following chapters are built upon these fundamentals. We will continue learning on classical mechanics in this chapter 6, work, energy, and power. I know that it's very easy to get overwhelmed around this point by the size of various keywords and terminologies that you have come across so far, the various laws and various sets of equations. I will highly advise you to endure them and make sure that you have learned the basic concepts clearly. If you are thorough with the introduction to the vectors, then you will realize how easy it is to understand how work done is a scalar product of the applied force and the resulting displacement. If you find it hard to grasp what I just said, then I would highly recommend you to go back and clear your doubts in the introduction of elementary concepts of calculus and vectors, because we will soon see how we can use integration to define work done by a variable force. Moving forward, you will have the concepts of power, potential energy, conservative forces, and conservation of mechanical energy. And then you can revisit the topic of conservation of linear momentum and how that modifies from elastic collision to inelastic collision. Make sure that you learn what coefficient of restitution is. The next unit is the motion of system of particles and rigid body, which contains only one chapter, system of particles and rotational motion. You can see how the simple and elementary understanding in physics can be transferred from simplified systems and geometry to complex geometries and systems. In this chapter, we will learn how we can break down complex systems into basic systems that we are familiar with. You will be introduced to concepts of center of mass, starting with a simple two-particle system and then moving on to the center of mass of a rigid body, and we will see some examples applied to a few simple geometries. Be prepared for a barrage of new terminologies. You will have terms such as moment of a force, torque, angular momentum, and its conservation. If you have not understood what these new terms mean, you should not enter the rest of the chapter where they will be extensively applied. You will have your part of fun in rotational mechanics, concepts of moment of inertia, radius of gyration, and how you could calculate them for basic geometries. And you cannot finish learning rotational mechanics without learning about parallel and perpendicular axis theorems and their applications. Before you move on to the next unit of how to modify this non-physics to non-rigid bodies, you have gravitation describing the forces between large heavenly objects over astronomical distances. Immediately after learning Kepler's law of planetary motion, you will have Newton's universal law of gravitation. Yeah, you heard it right. It's Newton once again. These laws will help you understand the way the planets and stars move. Here's the thing. Before Sir Isaac Newton propounded his universal law of gravity, people didn't walk on the surface of the earth, but rather they used to fly in the sky. It is very important for you to learn about acceleration due to gravity if you want to keep your foot on the ground. You should also know what escape velocity means, or you will be thrown from the surface of Earth. If you have been wondering so far about how all of this is going to be practical and be applied to everyday life, then I hope that the next few chapters will change your mind. Beginning with Unit 7, Properties of Bulk Matter, there will be 2 chapters dedicated to the mechanical properties of solids and fluids separately. While you have been learning the mechanics of rigid bodies, Chapter 9 Mechanical Properties of Solids is the mechanics of deformable bodies. Therefore, it will start with the concept of how to quantify the deformation of solid objects, which will be discussed as elastic behavior expressed in terms of stress and strain, Hooke's law, Young's modulus, Buck modulus, and modulus of rigidity, and Poisson's ratio as well. The next chapter, chapter number 10, is what is referred to as fluid mechanics, where mechanical properties of fluids will be discussed. I don't know if you have realized, but fluids cannot be treated as same as solid objects. I'm talking more than rigid bodies and deformable bodies. Deformable body at least can withstand shear stress, whereas fluids cannot withstand any amount of shear stress. Therefore, a dedicated branch of mechanics is required to study them, which is what fluid mechanics is. You will learn the concept of pressure due to a fluid column. You have Pascal's law about that. And you will have to learn new terminologies such as viscosity, Stokes' law, and terminal velocity. Then you will also have Reynolds number, streamline and turbulent flow, the critical velocity, and Bernoulli's theorem and its applications. You will learn why planets are round when you study the concept of surface energy and surface tension, the fascinating phenomenon of capillary rise, which seemingly violate your understanding of gravity or physics in general. This will be followed by next chapter on thermal properties of matter. You can enjoy this chapter as a general topic in physics as well as an introduction to thermodynamics, which is your next chapter. Here, you will learn to define heat and temperature. We will talk about the associated phenomenon of thermal expansion. It will be complemented with a few new terms such as specific heat capacity and latent heat. We will talk about different modes of heat transfer, which will be conduction, convection, and radiation. You will also be introduced to the concept of blackbody radiation. You will have one more laws from Newton's law of cooling. This will be followed by a dedicated unit on thermodynamics. So you will learn about the concept of thermal equilibrium and how you can establish temperature using zeroth law of thermodynamics. When you have understood the concepts of heat, work, and internal energy, then you can understand first law of thermodynamics. And when you have understood how entropy defines randomness of a system, then you can clearly understand reversible or irreversible process and subsequently the second law of thermodynamics. And to understand the few heat engines in the syllabus, just clearly understand the elementary process of isothermal and adiabatic process. Stay endure, for we are approaching the final units. For we have the last chapter on applying our understanding of physics to more complex and less understood systems. We will have Unit 9 on the behavior of perfect gas and kinetic theory, where we will establish a few basic and fundamental equations that defines the state of gaseous systems. While this unit and the previous unit of thermodynamics may seem to be repeating both in physics and in chemistry, it has been well assured while making the syllabus that your understanding complements from both the subjects. Never forget that what we are learning is natural science and they need not be very strictly bounded by walls of physics or chemistry. I hope that you will be truly fascinated by the kinetic theory of gases, about how you can develop assumptions about systems that you don't completely have an understanding of and still make sense out of it. And to the final chapter that describes the repeating or cyclic feature of nature, we will have the final unit on oscillations and waves. So you will learn to define periodic motion using terms such as period of oscillation, frequency, etc. And you will learn to define a wave using its amplitude, frequency, or wavelength. But for the following parts where you will start discussing topics such as simple harmonic motion, this may sound non-conventional, but I would advise you to get the necessary maths first. If you understand the essence of sinusoidal wave, understanding the spring mass system or a spring mass temper system and deriving their solutions would be so much easier. A little bit of differential equations and you would be able to see how they are the same problem. Same goes for waves and the principle of superposition. And don't get confused while learning about modes and harmonics. You will realize how elementary they are when you understand them. My humble request to you is to please make sure that you learn these concepts of waves because you will see their application once again in class 12. So this was about what you will see in class 11 physics. It should not be necessary to mention that this is not the entirety of physics even at school level, because as you can comprehend, we have not discussed even what's there on the picture, such as this relativity physics or the quantum physics. There's a whole lot of electrical phenomena to be discussed, magnetic phenomena to be discussed. There's also the optics, or the atomic physics, all of which you will see in class 12. And if you're curious about what's more in the basket, check out the next part of the series where we will talk about what's in class 12 physics. So that's it. Hope you enjoy it. And if you find this video to be helpful, then don't forget to like the video and subscribe to the channel. Thank you for watching, and I'll see you next time.